Welcome to this video by ARE11 Steel Detailing on stair project setup. Let's showcase an example project here where we have a multi-flight stair tower. Here you can see some of the plan as well as elevation views that we have involved with this stair tower. Now, what are the different typical things that you need before you actually start doing a stair job? Well, the first thing is that you definitely need the design drawings, and you're most likely going to be working off an architectural set of drawings which show the main dimensions of the enclosure as well as the dimensional inputs such as the run and rise or landing locations of the stairs. And then structural drawings might be there if the engineer of record has done the structural design for sizing the stair stringers and some of the connections and landing materials. Or if that's actually being done by Rexconn Design, where we actually do structural design of the stairs, then we're going to be coordinating with them to get the structural design package. Then you're looking for specifications, and oftentimes we're going to get paint, rail diameters, as well as building code specifications that we're going to be working to in those specifications. Then we're going to be looking for the scope sheet, and this is pretty important when you're doing miscellaneous because you want to make sure that you completely understand what is your scope, especially if you're just doing the stairs on a project versus the structural scope that's actually on the project. Then you want to make sure that you ask about a BIM execution plan. If again you're the miscellaneous detailer on the project and then there's a separate structural detailer on the project, maybe they have BIM requirements and files that they're producing for coordination, and you may need to be producing those as well for your stairs. Also, it might be a good idea is if the structural detailer is using a 3D modeling system, if you can actually get an IFC file or a 3D DWG or some sort of BIM reference that you can bring into your model, so that way you can actually see how your stairs may potentially work with their steel. Then you're going to want to get the Fabricator detailing standards. And stairs and rails oftentimes require more specific things for a fabricator than even sometimes standard structural. And so you're going to want to make sure you get this to follow any dimensioning styles and piece marking styles that the fabricator is looking for. And then lastly, but really importantly, what is the schedule with key milestones? And you're going to see here some of the process that we do at ARE11 is a little bit different than just doing structural where you fully detail something and submit it for approval, get it back from approval, and then submit it for fabrication. We're actually going to do stairs in a couple of different increments here, so that way we don't have to redetail the stair fully multiple times. So getting a schedule and understanding what the first approval dates and what the fabrication dates are and how this process is going to fit that is really important. Hands down, one of the most important concepts in steel detailing for stairs is understanding how the customer does stairs. So is the fabricator that you're working for, do they do stairs and rails all of the time? Are they a specialty stair and rail fabricator, or is this just something that came along in the structural package for this particular project? Do they understand some of the nuances as far as what information needs to be on the drawings for the stair design and dimensions to be complete? Are they expecting you to fully detail all the stairs and submit for approval in the first go round, or can you just submit erection drawings clarifying dimensions? How good are they at actually going out and verifying field dimensions? These are all concepts and things that you want to understand from the customer, not only in their fabrication and erection process, but in how they work and coordinate with the design team and the general contractor. This can drastically affect our price as a steel detailer and also affect whether or not we're going to be on time and on budget. All right, so what are some of the typical budget busters that cause you to have to detail the project more than 2 or 3 times? Well, the first thing that you want to evaluate is how complete is the architectural design. Are stairs and the enclosures fully dimensioned? Are landing elevations shown? Are the nosing points and the riser heights fully dimensioned and the quantity of riser heights? And are some of the dimensions and things that are actually shown on the architectural drawings, do they actually meet building codes? So, some fabricators actually specialize in design assist here, or actually working with the architect and the contractor to come up with some of these dimensions. They'll work off the conceptual floor-to-floor heights, and they'll use some of their expertise to come up with the best stair system that fits that. And then they'll hire a delegated design engineer, such as Rexconn Engineering, to do the stair design. Now, what comes with that, though, is that means that there's more detailing involved, and you want to detail in steps, first working out the geometry and the dimensions before you fully dimension and make the shop drawings on your stairs. And that's part of what we're going to show here. The next thing you need to understand is what's the stair enclosure system, and does that affect the stair being installed before the enclosure is put in or after? So what I mean there is if we look at the concrete or a masonry system that's going to be enclosing the stair, then that oftentimes will actually be put up before the stair is installed. So because the stair is going to actually frame into the cast in place concrete where there might be embeds or expansion anchored or wedge anchored to a masonry wall, basically what you need to do is you need to have dimensions fully clarified, and you're going to need to maybe potentially detail the stair broken down, and it has to be field fabricated because of access, since the enclosure is mostly already out there on the job site. If you have a stud framing enclosure where it's just stud walls, oftentimes the stair system is going to support itself. It'll either be sitting on structural columns and framing to a landing where the stairs sit on the landing or attached to the landing, or the stairs may partially hang from the structural steel that's already out there on the job site, and then the stud walls are then going to be placed and enclose the stair afterward. So this is really important because this affects the design. Then what are the stairs framing to? Are you doing drop-in stairs that are just going to attach to the landing, or are you going to do dog legs stair stringers and then the landing steel actually frames to those stringers? That's really important because certain erectors may want to do it a certain way that might be easier for them. I've always found that when doing stairs, it's easier from a steel detailing as well as from a erection standpoint to do drop-in stairs where the stair assembly is just lower onto a landing assembly and framing that's already there, and that's the best way to go if possible. Then you just have to look at whether or not you're going to be doing hangers from structural steel, or are you going to be sitting on columns, or are you going to be expansion bolting your stairs or wedge anchoring or attaching to embeds that are in concrete. And you also want to check that if any of your stairs are connecting to existing cast in place floors, like from the structural floor system, you definitely want to verify dimensions, especially opening dimensions, before final detailing. Almost always near the stair towers, there's something that differs from the design, and you want to get as-built information and dimensions and make sure that your stair detailing is going to match that so that we don't have to redetail multiple times. Then lastly, understanding the stair schedule. So part of this affects is what is the enclosure, right? Whether concrete or stud framing, but really understanding the stair schedule. If the structural is going on at the same time, in some cases, some stair towers are actually used as egress during the erection process, or during the job site when they're actually doing things. So if the stairs need to be used during erection as well as for final use after the project is complete, then the stairs are going to be in a rush at early phases. If the stairs are just being installed afterwards, after structural erection is complete and finishing is starting to go on, then basically that may impact the schedule to be a little bit later on the project. So that's what's important to also understand about the stair schedule, is just how much of a rush and how fast do you need to get these stairs out, and where do you sit in the overall project schedule and scope. All right, so let's dive into part of the sample project I was showing. Here we can see that we're missing landing elevations on this set of architectural drawings. We can clearly see how many number of landings that the architect wants us to put in, but we don't know the exact elevations. We also don't know some of these landing setbacks. It doesn't look like the landings actually go all the way to the walls of the enclosure of the stair, and none of these are dimensioned, so we'd want to understand exactly what's going on here. Then there's no nose and point dimensions. It does show in some sections and details maximum riser height, and I guess we could derive based here on the number of treads. We could calculate some of these values, but there is nothing specifically shown here, and we can see that there are some different runs of stairs at different floor-to-floor heights. Then we kind of look at the roof section here, and on the image on the lower left, you can see that the roof appears to be sloped, but the stair is going up higher here. And then we can see a small concrete slab, but we don't know exactly how this stair is going to interact at the roof level. So this is again a question of how do we coordinate with the existing structural, and what's the as-built conditions out on the job site, and is there maybe like a rooftop structure here where their stair comes in and you can exit out of that rooftop structure to go out onto the roof. That's something that we would need to coordinate and find out. Then also, if you look here, there is some magenta like piping, looks like water piping here that's in the stairwell, and it actually currently drawn interferes with the stair in some cases. So we would need to understand what's going on here. Does this affect our stair design? Do we need to work around this? And this is something that I would probably RFI. So when we look at the plan view, we can see here that there's missing dimension as far as where the enclosure is, like, and what is the enclosure size of the stair, and how does the landing and nosing points actually fit within that enclosure, so that way when somebody comes into this room, we know exactly where they're going to start going up the stair or exiting the stair. Then we also have changes in the stair enclosure as you go up through the building, through the height of the stair tower and the elevation of the building. At the lower level, we can see that we're working with cast-in-place concrete as the enclosure, but then when we start to go up, there's going to be some concrete walls as well as what appears to be stud walls as a finish as well. So this may impact how we detail and how we frame our stairs and support the framing structurally. Now, when you first start detailing, you're going to review the design drawings and you're going to start looking for RFIs as far as missing dimensional information or unclear dimensional information that surrounds your stair. So really, when you start the modeling process, you want to get the grids in, you want to model in the concrete, the enclosure, and you want to model in any of the existing structural steel that your stairs may frame to or interact with. Now in step 2, I start laying out the geometry of the stairs, rails, and supports. I'm not fully detailing all of the stair. Now what a lot of people do in the 3D modeling systems is they'll use the components that are built in and they start fully applying all of the detailed stair and rails and everything in the model. Now the reason why I don't do that is because it takes a little bit of time for those components to actually modify and update, especially when you're trying to tweak the geometry and get things to work. So what I like to do is I use lightweight custom components or just model in the stringers and nosing and construction lines, and I get this to work first. And I start looking at the primary post locations and I start seeing how the landings and things might work based on the geometry. This is where I start to identify where I may need to move posts to work with my stringers, and my guardrail system to work together. I might see the transition points between the one leg or flight of stairs to the other. I might see here on the landing steel that it may not work with the stringers that I want to attach to, and I've got to do something more creative or talk with the design team and the engineer. But these are all things that you can quickly do if you're just laying out the main stick geometry and getting this nailed down first. Then you want to fully check this and review this, and even potentially go ahead and make erection drawings of this stuff first and submit that out for field dimensioning and field verification, or even submit the erection drawings only for approval before you do any full-on detailing or make any shop drawings. This is really crucial here. Imagine if you didn't have these dimensions or some of these things clarified before you start fully modeling and connecting and detailing everything, and then even making shop drawings. That can be up to 60 or 70% of the cost on your detailing. If you do all of that work and then it comes back that those dimensions change or something needs to be redone, then you have to redetail about 70% of your work, or you're going to be modifying a lot of that and dealing with piece mark changes and chasing through all of the updates everywhere. So this is where in the process, if you know that there's a lot of missing information on the design, or there are field conditions that you need to verify first, especially with cast in place, then you want to send erection drawings out for approval, get field dimensions first, get that information back and clarified, and then start your detailing. All right, so after the approval process and field verification process of your erection drawings, here are some of the next steps. First being that you want to make sure that the fabricator releases you to do final detailing, and you want to try to get that in writing, just so that way there's an official transfer between you and the fabricator, so you both understand that, okay, now you're moving into the heavy hours of the detailing process on your project, and we need to make sure that all of the dimensions and the design is pretty well set before you start that detailing. And you may even come to an agreement with the fabricator that, hey, any changes or things that are imposed after that are then going to be considered a change order. Then what you're going to do is you're going to start updating the model geometry, and you want to fully check all this. So you're going to take all your conceptual geometry and modeling that you did, and you're going to change it, update it, and have a checker come in and make sure that everything's right. It's almost like you're doing a framing check here before you again start doing all the final detailing. If anything is incorrect on this core geometry and layout of the stairs, all your detailing could potentially be messed up, or there are going to be errors that propagate into that. After that, you start to input the detailed level stairs and rails in the model, and you may even completely delete or wipe out the conceptual geometry and stringers that you did. You may start to use the out-of-the-box 3D modeling system components that automatically do some of the stairs and the pans and the other information and connections that you need. Now that you've got all that geometry properly set in the model, you can start applying that detail. From there, you're going to do numbering and you're going to start creating your shop drawings. And then you'll finalize your erection drawings, submit for a final approval or an official approval if needed. So depending on how you worked with the fabricator and the contractor, whether your erection drawings went out for official approval or if you were just getting preliminary approval and dimensional finalization or design approval, you may do a separate second approval for detailing once all that design is complete and done. Or if you've already gotten everything off the erection drawings approved, you'll go ahead and submit your shop drawings for fabrication and your stair is complete. Now, here are some key things that you might want to ask the fabricator about how their processes and things work related to stairs. First thing you're going to want to ask is, do they like to detail the stairs and have the shop drawings in position or flat? In most cases, in the fabricators I've worked with, they want the stairs actually shown in position, how they're going to be put in the field. But some fabricators want stringers or even stairs detailed flat because that's how they may lay those out and fabricate them in the shop. Then you want to take a look at if you're doing built-up stairs, do the stringers and all the submaterials on the stair, do those need to have submaterial marks, or should there be one main part that all those submaterial marks attach to, or can one of the stringers be the main part? Oftentimes in the 3D modeling systems, it'll make one of the stringers the main part of the assembly, which may not be what the fabricator wants. So in cases where I need all of the submaterial or all the pieces in the stair to be submaterials, I will then put a dummy part that has a 0 weight at the bottom of the stair that just goes along the run, so you can see it in blue there. And then I just attach all the other parts to that particular dummy part, so that way it calls out in the bill of material as a stair assembly and everything is submaterial to that. Also, the advantage of putting in like that beam part, say for instance, and Tekla as a dummy part, is it actually allows you to control the assembly coordinate system a little bit more easily as far as how you want your stair detailed and the views that you want to create. So that's another advantage of going that way if you choose to use this option. Then you want to ask the fabricator how do they want like their Z pans or their bent plate pans and how they want their single part drawings shown. Some fabricators want like what you see here, which is an unfolded plate drawing, which actually shows the bend lines and then the bend angle. And then some want actually a cross section of the Z-pan with all the bend dimensions fully dimensioned that way. So that's something that you'll want to get verified with the fabricator. Now sometimes you'll need to leave a bottom or top pan loose for the stair installation access, or you may even cut holes in the bottom pan and send out patches to the field to be welded afterwards. So you can see in the image here that I'm at the bottom of the stair where we're expansion anchoring into the concrete, and so I may need access holes to get my hands in there or get equipment in there to actually tighten and put that bolt in. Or you just may ship that whole bottom pan loose as a separate assembly and then field weld that into place. Another really critical thing is what are the type of handrail brackets and end caps and things like that that you're going to actually use on the handrail, and what are the specific vendor information or product numbers that you're going to be using. Oftentimes I've done a lot of stairs where I'm using Wagner products as an example, and so this is something always good to ask the fabricator exactly what they're looking for, and even watching out on the specifications or even the architecturals, because the architect may specifically be looking for something that they're wanting on the stairs as well. Then verify always with the fabricator any special paint and clean spec, and make sure that you double check between the design drawings and the specifications. Oftentimes there's a lot of standard information and language in the specs that may be conflicting with what's shown on the design, so you totally want to make sure that you verify this with the fabricator and that both of you are interpreting things the same way. Another big thing to check with the fabricator is their requirement for all welds and rough or sharp edges to be ground smooth. In some cases, the architect actually wants completely smooth, so it's finished, so you can't even tell a weld was there. And then other fabricators and architects are okay with just smooth to touch. So they just lightly clean it up to make sure there's no slag or anything there, and that nobody can kind of hurt their hands when they run their hands across the handrail or surfaces. Then lastly, on handrail, you want to check, does the fabricator want lineal footage or a total length of all the handrail material on an assembly, or do they want cut to length pieces as well as piece marks with exact lengths for each of the pieces that are part of a handrail or a guardrail? Within Tekla, for instance, there's an option to switch between lineal footage or having individual piece marks in the bill of material, and so that's something that you'll want to verify with the fabricator. Now, like we've had in our structural project setup training, drawings and marking strategy are important. So what are the typical sheet sizes that the fabricator wants you to use? One piece per sheet, which is pretty much what you typically do with stairs. You'll put one stair per drawing, especially if they're built up stairs. Do you provide single part drawings or workshop drawings? How are the erection drawings going to be numbered? And if you're also working for the fabricator that's doing the structural, maybe they have structural erection drawing series numbers, and you need to find out what your stair erection drawing series numbers are. Find out what the revision labeling is, title block and bill of material requirements, and even ask them to send sample drawings. Again, stair drawings can sometimes take a lot of manual cleanup time depending on the standards of the fabricator. If you just do the dimensions and stairs all by yourself without any fabricator input or looking at their standards, you may end up finding that you're going to have to do some redetailing. Then, of course, looking at piece marks. Stairs are a lot more complicated as far as the number of pieces involved, especially some material parts compared to, say, a standard structural member. So really making sure that you have all of your prefixes and your numbering series and names of parts and items in the model set up correctly will be really important. So that way you can have that stuff set up. By the time you get to shop drawings, you don't want to be dealing with or catching any of those issues, so you don't have to go back into the model and fix things and then update your drawings. So to summarize our training, the two most important concepts that I'd like you to take away is first, understand how the customer does stairs. So not only from both the fabrication and the field process, but also from the bidding process and the design assist or design coordination process between the fabricator and the contractor and design team. How much does that fabricator typically work with the design team and the contractor to act as a design build partner, or are they purely just fabricating a fully designed stair that they're bidding and working from? Then lastly, verify your geometry and your information before you start doing the full detailing on your stairs. You want to make sure all the geometry, landing points, all the enclosure information, field dimensions are fully verified and you have everything before you start making your shop drawing and doing your final modeling. That way you can make sure that you're staying on schedule and you can be profitable at decent prices with your stairs.